Veteach. Today I am going to explain about the feedback amplifiers. So, what are the feedback amplifiers and how can we analyze the feedback amplifiers, and that all will be explained in this chapter. So, before going to the feedback amplifiers analysis and the purpose of the feedback amplifiers, now first of all we have to know what is feedback. So, what is the purpose of this feedback? So, this feedback provides it plays a very important role in the electronic circuits. So, it plays a very important role in the electronic circuits, which changes the input impedance, so input resistance, output resistance, gain and bandwidth. So, in order to change all these parameters, we are using this feedback. So, this feedback provides using of the feedback, we can change the input resistance, output resistance, gain and bandwidth of the electronic circuits. And if you see in the large signal amplifiers, so if you see in the large signal amplifiers, the main problem is nothing but a distortion. So that distortion also can be eliminated by using of this feedback. So this feedback is also can be useful, so that can be done. So this feedback provides the gain is independent of the circuit parameters. So feedback changes that gain as the independent of the circuit parameters. That means if you make the gain as independent of the circuit parameters, what are the circuit parameters are existed? So that is nothing but the transistors and capacitors and all these things. DC voltage sources are existed in the amplifier circuits. If any of the parameter is changed in the circuit, then automatically the gain will be changes, and that we can be eliminated by using of this feedback. So this feedback makes that the gain of the amplifier is independent of the circuit parameters. So these are the uses of the feedback. So feedback is used. So if we use this feedback, then we will change all these values. And here, so what is the feedback? So what is the definition of the feedback? We will see what is the definition of the feedback. So what is feedback is nothing but, let us consider an amplifier circuit. So let us consider an amplifier circuit. A portion of the output is again gives to the input. A portion of the output signal is again gives to the input signal and mixed with that of the source signal, and which again gives to that of the amplifier. A portion of the output signal gives to that of the is mixed with the external signal and which is gives to that of the amplifier. Then the gain will be changes. That is called as the feedback. So that is called as the feedback. A portion of the output signal which is taken from the output of the amplifier and is combined with the normal input signal. That is called as feedback. Now, before going to feedback amplifiers, now generally what are the amplifiers will be presented, we will see. So these are called as the basic amplifiers. And what are the classification of basic amplifiers? What are the different types of amplifiers is used in the feedback amplifiers? Those are nothing but the basic amplifiers generally classified into 4 categories. Those are nothing but, first one is voltage amplifier, second one is current amplifier, the third one is transconductance amplifier, and fourth one is transresistance amplifier. So the classification of feedback amplifiers, these will be classified into 4 different types: voltage amplifier, current amplifier, transconductance amplifier, and transresistance amplifier. Now we will see the circuit diagram of the voltage amplifier, current amplifier, transconductance and transresistance amplifiers. Now voltage amplifier. So this voltage amplifier is nothing but the output is, so in terms of the voltage. So if you see that voltage amplifier as the output is voltage and as well as the input is voltage. Because of both are voltages, we are using the Thevenin's equivalent circuit in order to represent this voltage amplifier. So So the output is Thevenin circuit and the input is Thevenin circuit. In order to, so voltage amplifier, what are the conditions of the voltage, for an amplifier is said to be voltage amplifier, what are the conditions we have to follow? That is nothing but whatever the signal voltage is, whatever the source voltage that we are giving, the total voltage must be appeared across the input of the transistor. This is nothing but the transistor. The transistor will be replaced by approximate model. So here an amplifier is said to be the voltage amplifier. That amplifier is said to be voltage amplifier. That means that is nothing but whatever the source voltage is given, the total voltage must be appeared across the input of the transistor. So that is nothing but in order to make Vs is equal to Vi, in order to make Vs is equal to Vi, the voltage drop across this resistor should be very lesser. So when will be the voltage drop across this resistor will be very lesser? Whenever the Ri value, the input resistance, so Ri is nothing but the input resistance of transistor. The input resistance of transistor. Whenever the input resistance of the transistor is very high compared to that of the source resistance, then the total voltage will be developed. So the value of Vi is equal to Vs. Similarly, the total output voltage we have to consider. So generally voltage amplifier V0 is equal to V0 by V in. So that is nothing but V0 is directly proportional to Vi. So the in order to get the total output voltage, what is the output voltage here? AV into Vi. In order to get the total output voltage across this load resistor, so what is the condition? The value of R0 must be very lesser when compared to that of the RL. Means the load resistor value will be high. So we know that whenever the resistance is high, the voltage across that particular value will be very high. That is a simple phenomenon we have to remind. So in order to get the total output voltage, the load resistor value should be high. Means the output, what is R0 here? R0 is nothing but the output resistance of transistor. Output resistance of transistor. So transistor is said to be a voltage amplifier. The value of Ri must be far greater than Rs, and the value of R0 must be far less than RL. This is the condition. If this condition is satisfied, that amplifier is called as the voltage amplifier. And the output voltage is directly proportional to input voltage. This proportionality constant is nothing but the AV, which is independent of source resistance and the load resistance. So for an ideal amplifier, it has Ri is equal to infinite and R0 is equal to 0. But practical amplifier, it has the values of Ri is far greater than Rs and R0 is far less than RL. This is the voltage amplifier. Now the second amplifier is the current amplifier. So what is current amplifier? Current amplifier is nothing but the output is current as well as the input is current. Because of these currents, the circuit will be replaced by using Norton's equivalent circuit. So here, in order to, an amplifier is said to be a current amplifier. Whatever the current we are giving, the total current must be appear across this Ri. So when will be the total current will be existed? The value of, we know that whenever the resistance value is very less, then the amount of current passing through that resistance will be higher. So by using that, then the value of Ri must be far less than that of this Rs. Means the value of Rs should be very high. Whenever the Rs value will be very high, it will be acts as a open circuit. Then total current is passing through the transistor only. And similarly, in order to get the total output current I0. So total output current I0, what is that value? This R0 should be R0 value. So in order to pass the total current through the load resistor, so it should be acts as an open circuit. Means the value of R0 should be very higher when compared to that of this RL. So an amplifier is said to be a current amplifier. The conditions must be satisfied as Ri must be far for means the input resistance of the transistor must be less than that of the source resistance, and the output resistance of the transistor must be greater than that of the load resistor. In such cases only the current amplifier, that amplifier is called as the current amplifier. So the value of I naught is directly proportional to II, so which is nothing but Is. So if you take the value of I naught is equal to Ai into Is, and this Ai must be independent of RL and Rs. This is the current amplifier. And one more amplifier is nothing but the transconductance amplifier. So what is transconductance amplifier? You know the definition of the transconductance. So this transconductance is represented by a letter Gm. So what is transconductance? Ratio of the output current to that of the input voltage is called as the transconductance. Means the output circuit must be a Norton circuit, and whereas the input circuit must be a Thevenin circuit. The output is Norton circuit and the input is Thevenin circuit. So here the input circuit is replaced by the Thevenin's equivalent model, whereas the output circuit is replaced by the Norton's equivalent model. So same conditions, in order to get the same whatever the supply voltage, external voltage is given, that to be appear across the input of the transistor. This is nothing but the transistor. So whatever the source voltage is equal to Vs is equal to Vi, the value of Rs. What is the value of Rs? Should be lesser. Means the value of Ri must be far greater than Rs. Similarly, whatever the current which is developed in the output of the transistor, the total current must be flows across this RL. Hence, the value of R0 must be a open circuit. That means the value of R0 must be far greater than RL. So these are the conditions for the transconductance amplifier. An ideal amplifier, it has the Ri is equal to infinite and R0 is equal to infinite. But practically it is not possible. Practically we have to take the transconductance amplifier conditions as these two. And so here the output current is directly proportional to that of the input voltage, and so if you, this proportionality constant is nothing but Gm, and it must be independent of the source resistance and the load resistance. And the next one, the last one is the transresistance amplifier. So what is transresistance amplifier? We know that the transresistance amplifier is represented by the letter Rm. So what is Rm? Rm is equal to output voltage to that of the input current. So output voltage to that of the input current. What is output voltage? So because of the output is the voltage, you have to take in it as Thevenin's equivalent circuit, and the input is current. So that's why it is represented by Norton's equivalent circuit. So the conditions, in order to make the total Is is equal to Ii. So Is is equal to Ii, the value of Rs should be behaves as a open circuit, means the value of Ri must be far less than Rs. So Rs, and similarly here, in order to appear the total, what is here, the output voltage is nothing but Rm into Ii. In order to appear the total output voltage across the load resistor, what is the value? The voltage drop across this R0 should be very lesser. So hence the value of R0 is far less than RL. So for a practical amplifier, sorry, for a ideal amplifier, the value of Ri is equal to 0 and R0 is also equal to 0. But it should not be possible. Hence the conditions are Ri is far less than Rs and R0 is far less than RL. And here, so the output voltage is directly proportional to depends upon the input current, and so this proportionality constant is called as the Rm, and it must be independent of the source resistance and the load resistances. So these are the 4 different types of the basic amplifiers are used in the feedback amplifiers. Thank you.